Okay. So I'll finish up the rest of the practice exam here. All right, starting with question number 11. This is looking at fractional reserve banking. So there's going to be $500 currency to start off with. So this is what the monetary base is. I'm starting off with $500 currency. Now, of course, as people deposit it and these banks hold reserves, well, then the monetary base becomes like a combination of reserves and currency. So, okay. So banks are going to hold the reserve ratio 30% of their deposits as reserves, and they'll loan out 70%. So let's fill out this balance sheet here. This household, they're going to deposit this $500 in First Bank. All right. So on the left-hand side is their assets. On the right-hand side is their liabilities. What can be their assets, reserves, or loans? They're either going to hold it on hand at the bank as reserves, or they're going to loan it out. What about liabilities? The only thing we have here is deposits. We're not going to look at bonds. We're not going to have any capital on these problems. And so this person is going to deposit $500 into the bank. So that's the deposits. They'll have this money. They can spend it. This is their checking account. They can spend this by writing checks, using Venmo or transfer, using a check card, debit card, whatever. And so the bank is liable for this money. If this person's like, hey, I want to send this money, the bank's liable for it. They need to process it for them. All right. How much are they going to hold of this money as reserves? Well, reserves are going to be $500 times the reserve ratio, which is 30%. So they're going to hold $150 in reserve here. And they'll loan out the rest of this. 500 minus 150 is 350. Remember, these sides are always going to be equal to each other. 500 here on this side and 500 on this side. Okay, so First Bank is making 350 in loans. What about the money supply? Well, the money supply is currency plus deposits. The currency, well, that's his loans. When the bank's loan this out, they're giving the current currency to this person who's taking on a loan. What about deposits? Well, that's $500. So the money supply now is $850. So it grew by $350. So what happened? This person deposited their money with First Bank. They still have access to this money in the form of deposits. But since people that deposit money with the bank, they don't spend all of it at once, or they don't come back and claim it. So the bank's like, well, okay, I'll do something productive with a portion of it. And so they loan it out. And when they do that, they're increasing the money supply. It's expanding from 500 to 850. And so depositors, like we said, will have 500 in demand deposits. And the borrowers have 350 in currency. Okay. All right. So now we're going to say, okay, well, this borrower here, he's going to deposit the $350 into Second Bank. So we'll see what happens here with that. Okay. Second, let's get this erased, then I can. There we go. Second Bank's Balance sheet will be defined here. And so this person, they're going to deposit the whole $350. So now Second Bank has $350 in deposits. And just like First Bank, they're going to hold 30% in reserves. So 30% times 350. This will give you 105. So they're going to hold $105 in reserve, and they're going to loan out the rest. So it'll be $245. All right, so Second Bank is making $245 in loans. The money supply, what's it going to be now? Remember, it's currency plus deposits. The currency is $245 now. What about deposits? Well, you have the $350, but don't forget, you also have the original $500. That person still has use of those deposits in First Bank. So now the total money supply is $500 plus $350 plus $245. So the money supply is expanded now from $850 to $1,095 when Second Bank took these deposits and loaned out a portion of them. All right, so depositors have $850 in demand deposits, and the borrowers have $245 in currency. Okay. All right, so we'll say, okay, what if this process keeps going on and on? Person took out this loan, they don't keep any of their money as cash, they're going to deposit it all into another bank. And then somebody's going to take out a loan from the bank, 70% of it. They'll keep 30% of the deposit reserves. And this process just keep happening over and over again. What would the money supply end up being if this happens? So we'll use our special case money multiplier. Ooh, there we go. 1 over the reserve ratio. So 1 over 0.3. This is going to give you 3.33. So the money supply is 3.33 times 500, our monetary base that we start out with. So that's going to be $1,000 and $1,665. Okay. So that's going to be B. Go. Now what's C asking? Well, here we're saying that the bank's going to increase the reserve ratio to 35%. All right, maybe they're a little bit worried about, the economy, or maybe things are looking a little bit sketchy or whatever. So they're going to increase the reserve ratio that they hold. And also, households, instead of depositing every bit of their money, they're going to keep some of it out as currency. And so now the currency reserve ratio is going from 0 to 0.6 now. Okay. So now we use our formula for the money multiplier. It's a cash reserve ratio or currency reserve ratio plus 1 over the currency reserve ratio plus the reserve ratio. All right. So this is going to be 0.6 plus 1 over 0.6 plus 0.35. So our money multiplier now is going to be 1.68. So what's our money supply? Well, it's just the multiplier times the base. The multiplier now is 1.68. The base, we're still going to use $500. And so now that's going to be $842.11. So you can see that's a lot less. It's half. The money supplies, went in half because on the one hand, banks are loaning out less, they're keeping more in reserves. And also, households are keeping some of their money as currency. They're not depositing it. And so without these deposits, with this lower amount of deposits, well, the banks can loan out less of it, like engage in fractional banking with a lower percentage of the monetary base, because people are holding on to it. So both of those things decrease the money supply. All right, so let's erase this and then do D. Okay. So now we got another balance sheet for First Bank. And now we're going to have the bank holding capital. And they're not just making loans, they're also making investments as well. Okay. So the households are depositing $500 still. $500. But also the bank, they raised $25 in capital. They issued some stocks. People bought these stocks, and now they're holding that money there, and they have that as capital. Okay. What are reserves going to be? Once we do that, we'll find a loan and investment. Well, they're going to hold 20% of their deposits as reserves. So 20% of 500 is 100. The rest of the money they're going to make in loans and investment. So remember, this asset side has to be equal to the liability capital. And the liability capital side is 525. We've got 100 of it in reserves, so we know 425 is going to be with loans and investments the banks make. All right. Well, the bank's going to lose 10% on the value of their loans and investments. So how much capital will the bank have? So you'll take this 425, multiply it by 0.9, and what you'll get is $382.50. So now we can calculate capital. Just assets minus liabilities. That's $482. Yeah, that's right. $482.50. Because the loans investment is $382 and reserves are $100. So that's our total assets. What are the liabilities now? Liabilities is the deposits. And it's $500. So it's actually going to be negative $17.50. The bank's in the red. They're insolvent at this point. All right, they're in trouble. All right, they either going to have to raise capital or they're going to go bankrupt. Okay. All right, so that's it for the fractional reserve banking. Let's see. Now, let's look at 12. This is looking at bank runs. So what do we have going on here? We have 100 depositors. They're depositing $100 each. And the bank has access to investment opportunities, which pay 10% rate of return. It's held to it's matured for 2 periods. So R2 is equal to 1.1. But if the bank liquidates earlier, they just get the money back. It's 1. All right. What about the depositors? They're doing business with the bank. Well, they're impatient with a probability of 50%. And they're patient. That is, they'll pull their money out after 2 periods, let it, full time. Nothing will happen with them with the 50% probability. Minus P is. There's impatient depositors. Well, something came up. They had a liquidity shock. They needed the money. Car broke down. Some medical bills. Had to buy some clothes for the kid. Just something came up. They need to pull some money out real quick. Okay, so the bank knows this. They know that, on average, about 50% of the depositors will show up early. 50% will be patient. All right, so the bank's going to offer a return of 1.03 as a 3% interest. What we need to find is R2. Okay, so that's what we'll do now. So at time period t equals 0, that is the start of this. These 100 depositors show up. And they're each going to deposit $100. Okay? With the bank. What's the bank going to do? Well, it's going to take this 100 times $100. This will give you 10,000. They're going to take and put this 10,000 in the investment. So the deposit base is $10,000. Okay. All right. Now what happens at time period t equals 1? Well, this is when the impatient depositors show, the ones that had a liquidity shock, and 50% of them, each depositor had a 50% chance of this happening. So 50% times 100, there's going to be 50 of them show up. Wow, man, wrong way. So they're going to pull out their money. How much are they getting? Well, the bank promised 1.03. They each put in $100. So that's $103. Each one of them is getting 103 bucks. 39, 103 plus this one over here is getting 103. So 50 depositors are getting 103 each. So how much does the bank have to pull out? 50 times 103. And 50 times 103 is 5,150. All right. Just pulling this out from the investment. So how much is going to be left in the deposit base now? Remember, we started with 10,000. Remember, they're not going to receive any money on this. So this is still, it's going to be 10,000. And so they'll pull from this. I'm not going to earn any interest rate on this. So when they subtract 5,150, what she'll get left is 4,850. Okay, that's what the deposit base is now. Erase that. All right. So now this 4,850. Well, now it's going to pick up interest now because it's going to remain with the investment till it fully matures. So they'll get some return on that. And this will go into telling us how much these patient depositors, the remaining 50, how much they're going to get from the bank. So the bank's going to pull the remaining money from the investment. And since they're competing in a perfectly competitive market with other banks, you know, they're going to keep offering better and better rates until they earn no profit. So the bank's going to pay out every bit of the money that's remaining here to these remaining depositors. And so what will the deposit base be now? You take the 4,850, multiply it by 1.1. And what does this give you? Well, this will give you 5,335. Okay. There's $5,335 left. The bank will pull this all out, and it's going to divide it up between these 50 depositors. So what do they get? 5,335 divided by the 50 remaining depositors. So they'll each get $106.70. 49 times 106.70. All right. Each depositor gets 106.70. So what's the return? Let's do this. There we go. The return is just this 106.70 divided by what they originally put in. And that's just going to be 1.067. Okay, that's the return. You can say that, you can round it up to 107, whatever you want to do. 106.7. All right. Yeah. Okay. So this is R2, 1.07 or 1.067. All right. So now what we're going to do? Well, all right, so we went through the process. This is what the bank, based on what they expect people to how they pulled out, these are the returns they're going to get. Now, if you notice, people that withdraw early get a higher return than if they invested directly with investment. But people who are patient, when they pull their money out, they get less than they would have if they invested directly. One of the reasons people do this, they want to minimize their variance. They're trying to smooth out their consumption. They want to, minimize any sort of downside risk, eliminate that. All right. And this is what risk-averse people do. So the bank here is acting, kind of like what they're doing is they're risk pulling here. They're taking all these funds. And people don't know for sure if they're going to pull it out early or not, but they know a certain portion are, and when they do, they'll pull it out and they get a little bit higher of a return. Okay. What's B asking? Well, now there's going to be 75 depositors show up. Same 50 showed up, but now for whatever reason, maybe 25, they heard some bad news about some other bank. They got worried about theirs. Well, they want to go pull their money out, even though they don't need to. So 75 show up. They pull out their $103. So that's going to take out $7,725 from the investment. So what's going to be remaining in the deposit base? 10,000 minus 7,725. Okay. Well, this first question wants to know, what are the earnings the bank gets? Well, the earnings will be this remaining portion that's left here. I forgot to answer this. That's $2,275. This is what's remaining in the deposit base. So that's there you go. This $2,275 times the return that it gets of 1.1 minus what it starts out where, 2,275. What does this give you? $2,502.50 minus 2,275. This gives you your earnings of $227.50. Okay. So that's the answer to B here. That's what the bank actually earned. Now, they don't keep any of these earnings. They're going to pay them out, but that's what they earned by taking advantage of this investment. See? All right. So if there's any money left over, what do these patient depositors get now? What will they get in period 2? Well, it's going to be this $2,502.50. This is what's left over. This 2,275 is left over. It earns 1.1. There's $2,520.50. You divide this between the remaining 25. What do they get? Well, they each get $100.10. So the return now is like 1.001. As you can see, this is really low. This is lower than what the inpatient depositors were promised. So people are just going to get in line, try to get their money out on time now. These remaining 25, they weren't being irrational and jumped in line, even though the bank was in fine shape. But once these other people try to get their money out, well, at this point, it becomes rational to get in line, try to get your money out before everybody else does. otherwise you'll end up getting less money to begin with. And so this is kind of illustrates the coordination problem that happens. Like you can't get people to, if you get people to coordinate and work together, but people, they don't do that. They have their own interest. You can't really, without any like deposit insurance or anything like that backing it up. Well, this is what would happen. As you can see, what happened with Silicon Valley Bank with these deposits that were over this deposit insurance level, they got worried because they heard about this bank. Now they actually had legitimate reasons. They showed up and pulled their money out. When that happens, the bank's in trouble. D. So what are we doing here with D? Well, we are, let's see. We want to calculate, okay, so the bank wants to do something about this. I'm sorry, the government, they were doing a lot of these bank runs in the 30s. Like, okay, let's, deposit insurance, something we can do. So let's show in this model how they do it. And they do this by like implementing a tax. All right. Okay, more people show than what we thought. So we're going to tax you, you don't get as much. And then what this does, this forces people to be truthful. Like if they really need the money, then they'll go ahead and take it anyway, they're paying this tax. If not, they'll wait and be patient and wait till the last period. And what this does is quells the run. And only people that actually need the money show up, and then everybody gets what they're promised. But let's calculate the tax and show why this is the case. Why would people wait if they don't actually need the money? Okay. So how much money do people need? Well, let's erase this and start over. So I can get everything here on one page. All right, so this is part D. First, we need to find out, well, how much money do we need in time period 2 to pay out to these remaining 25 depositors? Well, they were each promised $106.70. All right, so multiply that by 25. This will give you a total of $2,670.50. All right, this is the amount that's needed in time period 2. For these patient depositors to get what they were promised. All right, now you don't need to have quite this much money left over when you're leaving time period 1, once you pay out all your early withdrawals. That's because the money that's left over is going to earn something. It's going to be put in this investment. It's going to fully mature, and then get a return for it. So we want to correct for return by dividing by R2. So we take this $2,667.50. We'll divide by R2, which is 1.1. And so what do we get? $2,425. Okay. So this is what we need. Now we need to find the shortage. What do we actually have left? If the bank was to pay out everybody what they promised in time period 1. The shortage. So we need 24.25. What do we actually have if they paid everybody out without taxing them? 2,275. So the shortage is $150. Now we calculate the individual tax. So we take this $150, divide by 75. It's a $2 tax on everyone. So what's the return for early depositors? Well, 103 minus the $2 tax. So now they're going to get $101. So what would that return be? 1.01. All right, so now they have a choice between getting $1.01 versus being patient and getting 1.0, was it 67? Yeah, 1.07. Well, now the ones that were trying to withdraw early, like, man, no, I don't want to do that. I don't need this money. All right, since I know those banks, they're going to step in with this deposit insurance, or the central bank's going to step in and like print the money, or one or the other. So now there's no point in me withdrawing. I can, be truthful and say, okay, I don't actually need the money. So only the people that actually need the money are going to withdraw now. And so this will allow everybody to get the return that they need. All right. This R1 is less than R2. Only depositors experiencing liquidity shock withdraw. Okay. All right. So now we have one more part. We want to draw this. We want to describe how do risk-averse individuals perceive this interest rate risk that they encounter? That is, why do the 100 depositors choose to use a bank instead of investing directly with investment? We use the detailed graphical analysis. That is, using the utility function. Here we said this was going to look something like this. Man, keep doing that. On the y-axis is the utility, x-axis is the income, and this is the utility they get from this income. It's diminishing marginal returns. Yeah. At first, at lower levels of income, any increase is going to give you a significant increase in utility. But as your income keeps rising, you care less and less about this income. That is, it increases your utility at a decreasing rate. All right, so we're looking at the decision here. All right. So we have one bad state here if they get a liquidity shock. If they was invest directly with this investment, they would just get their money back, $100. So this would be utility big R1 from the direct investment. But instead, if they invest with the bank, they get 103 here. So this is the utility from small R1, the return from investment with the bank. All right, now what about if they use the bank and they would, withdraw after 2 time periods? They'll receive $106.70. So this is the utility they get from little R2. All right, what about if they invested directly? Well, in that case, they would have got $110. So they would have got more money if they invested directly, if they didn't experience a liquidity shock. So this is within their utility here. Well, why do risk-averse people choose to use the bank? Well, they care more about this gain in the bad state. As you see, it's greater than the loss in the good state. Okay. Gain in the bad state when there's liquidity shock, when something goes wrong, is greater than the loss in the good state. Yeah, it'd been nice if they would have gotten this $110, but that they're worried more about losing this $3 here if they need to pull their money out earlier. Right? They care more about this money here at the lower levels. Risk-averse people, they want a smooth consumption. In the presence of liquidity shocks. Decrease variance. Why do they want to decrease variance? to avoid downside risk. It's not they don't, this gain, if they this increase the income they would have gotten in the good state would have been fine. Right? But they worry about this loss here. Right? They want to gain this bad state instead of gaining this good state, because it gives you more, it gives them more utility here. This is the way risk averse people are. They're more concerned about being able to pay their bills. They don't want to get behind on their bills. Yeah, it'd be nice to have a little extra wealth, buy a few nice things, but it's better safe than sorry. Okay, so that's it for, man, what is this thing's problem? There we go. All right, now our last problem, monetary policy and inflation. So we'll look at two central banks with different approaches to monetary policy. The first central bank from Japan only looks at monetary aggregates. The other central bank in Europe adjusts the money supply in order to hit an interest rate target. Now, they use the federal funds rate, but we'll just say the nominal interest rate was what they targeted here. For simplicity, we'll assume this is the nominal interest rate, and we'll say that velocity is constant. So A here, Japan has an inflation rate of 1%. If the Japanese economy is growing at 5%, what money supply growth should they target? All right. The inflation that they're targeting here is 1%. We'll use our formula. Remember, we said that percent change in money supply plus the percent change in velocity equals the percent change in price plus the percent change in growth in the economy. We said velocity doesn't change, so that's 0. So the change in money supply equals the percent change in price plus the percent change in growth in the economy, growth in GDP. All right, so what do we have? Well, we want inflation to be 1%, and the economy is growing at 5%. So the money aggregate should grow by 6%. Now, so that's A. Now, nobody does this anymore. It's too hard to keep track of money. This is what they used to do. They would, look at the money aggregate. Okay, we see this. We want to grow the money supply by this much. Let's keep track of that. They don't do that anymore. It's just they had a hard time keeping track of money because so many people use credit cards and other forms of payment. It just became really difficult to keep track of it. So what they do is they'll target an interest rate. And that's kind of what we'll try to emulate here in part B. In the European Union, the economy is growing at a rate of 2%. The percent change in Y is 2%. Additionally, the real interest rate is 4%. And the growth rate of money is currently at 5%. Okay. So what is the nominal interest rate? Well, the nominal interest rate is the real interest rate plus inflation. The real interest rate is 4%, but we don't have inflation. So we have to use this other information. We know inflation is a percent change in the price level, and that's just the percent change in the money supply. As the money supply increases, well, inflation is going to go up. That's because there's more money chasing the same amount of goods. But it decreases with the percent change in output. Because there's more goods, to be able to sell these goods, you're going to, firms are going to decrease the price of them. All right, so we can calculate inflation now, and then we can use that to calculate the nominal interest rate. Percent change in the money supply is 5%. Percent change in output is 2%. So inflation now is 3%. So we can calculate nominal interest rate. It's 4% for the real interest rate, and inflation is 3%. So adding these together will give us the nominal interest rate. Remember the Fisher effect. As inflation increases, well, the nominal interest rate is going to adjust. That's because, when banks or financial institutions are making loans or, somebody's taking, or a company's borrowing money, they're going to keep in mind what they expect inflation to do, what they expect it to be in the future. And they're going to make a contract accordingly. They're not always right. Sometimes they're off. But this nominal interest rate is going to adjust automatically. And so what it's going to be is 7%. Okay. If the European Union has a mandate of 2% inflation, what nominal interest rate should they target? Well, inflation's at 3%, but we want it to be 2%. So nominal, old target 4% the real interest rate, plus we want 2% target. This will just be 6%. Okay. So the I they should target is 6%. What nominal interest rates are, and what should the money growth rate be? Well, it needs to decrease by 1%. Needs to decrease by 1%. And what is it currently? We said it was currently 5%. So it needs to go down to 4%. Right, that's the percent change in money growth. All right. So at this interest rate, well, they need to clamp it down some. They want inflation to go down a little bit. So they'll decrease money supply growth by 1%, or try to do that. They'll look at the inflation target. I mean, the interest rate target, and try to get it to hit. And if they do that, then they'll hit their target, and inflation will be at 2%. Okay. All right. So that is it for this practice exam. Hope this was helpful. Okay.